everybody. Welcome to my talk on functional testing with Symfony2. And the title is actually a little bit misleading because not functional testing with Symfony2, but actually, as we will see, you can also apply this to Drupal or any other PHP application that uses the Symfony HTTP kernel. A little bit about me. I am working at Carrefour. It's a company based in Germany, and we are helping people to create high-quality web applications. And I'm also a Doctrine developer and responsible for release management and all the other little stuff that is happening in the Doctrine world. And I'm also a contributor to Symfony. And mostly, like 2 days before feature freeze, I sort of want to change everything and create tons of pull requests. And Fabian is probably very annoyed of this. And yeah, my Twitter nick is at Eberlei and also at Carrefour. Okay, so testing actually, well, okay, first some questions. Who's actually applied functional testing to Symfony application? Hands up, okay. And who actually hasn't seen more of functional testing than the default test case that is always generated for you for every bundle? No one? Just, okay. Yeah. Functional testing is just one part of testing in web applications in general. The one that the PHP community regularly put the most focus on was unit testing. And this is also because the primary tool for testing in PHP is called PHP unit, which actually focuses on the unit testing. And this is one thing that you see quite a lot about people teaching how to unit test. Then there are integration and functional tests. And these normally look at a much bigger level of your application and try to test many different parts of the application in one single test. And then there's acceptance tests, which are sort of a way for the product manager or product owner to specify requirements and let's say, when the user clicks there, then this and that happens. And then there's a class of tests which is called system tests, which are used to test your complete application from the front to the back end using a setup that is nearly identical to production so that you have a very rough overview on if your application works. So these 4 test classes are, the difference is that the unit tests are really small, executed in very, very few lines of code. And starting with the classes, you always add more and more code that is executed in a test. And also, the tests run much, much slower. So unit tests are supposed to run very fast, and system tests probably can take, even minutes or something just to set up the test. And then run just one simple system test, and it can take minutes or something to do so. So I want to talk a little bit about unit testing first before I come to the topic about functional testing. And unit testing actually is, if you take your application as sort of a house built of blocks, then unit testing is actually picking one block of your application and then putting a magnifying glass just on this little box. So we want to take a look at this certain part and only test this certain part. And we don't want to look at everything else. And because your application or your building blocks are actually neighbors to each other, they have dependencies to each other, in unit tests we actually try to make them go away. So we sort of build a wall or and then when you're doing unit testing, you will learn quite fast that you need something called mock objects to actually do real unit testing. And this is tries to help you focus just on the very, very simple units that you want to test. This is actually something that is quite difficult for developers to learn. So teaching people unit testing and really just focusing on the simple classes and abstracting away all the dependencies, this takes quite a lot of time to learn. And you have to learn object-oriented principles of object-oriented design, so-called solid principles, and you have to apply them to your code all the time to be able to actually unit test everything correctly and have this test that is easy and small and very fast to run. And this is actually something that, if we teach this to developers, it's actually taking lots of time and lots of experience to do so. And this is why it helps to start writing functional tests first, actually, because then developers actually, you can very easily start writing functional tests because you don't have to learn about how to separate the dependencies. And then, in a good software quality setup, you actually have like this multiple feedback cycles. It's not that you just write unit tests for your application. You also write acceptance tests or integration tests that look at a much, much bigger scope of your features. So in a perfect world, for example, it depends obviously on how you would like define this, but normally in an application where you apply quality measures or testing, the project owner would come with a new feature and you would immediately start writing like a simple acceptance test for this, and then have one test for this whole feature, or two, maybe three feature tests. And then when you start implementing this, you like get more and more and more unit tests. So much more unit tests than you actually have functional tests or acceptance tests for this. But you can skip the cycle and just have the functional or just have the acceptance test. It's perfectly possible as well. The trade-off actually is that tests like the system test, the integration test, and acceptance tests are actually much, much slower than unit tests. So the tests that cover lots of code usually take lots of time. And the unit tests are usually much faster. So it's very important to find a good mix between them, because once you have just functional tests and a lot of them, your test suite might take really minutes or up to hours to run, and then nobody's actually running the tests anymore because it takes so long. Okay, so what are Symfony functional tests? Symfony functional tests look at your application as an HTTP black box. It's sort of thinking about the application as a HTTP request being the input and the HTTP response being the output of the application. And everything else is just details or magic. Something happens. And this is done by implementing actually what the request response cycle as a client is, so a browser. So we have a browser object or a browser class that we're using for interaction with our complete application. And we are simulating in code that we actually have some client operating a browser, visiting our website, clicking links, submitting forms, changing the URL to something. And this is what Symfony functional tests do. And what we then do, if we have like sending requests to the application, then we're calling assertions on the HTTP response. So assertions are actually methods that allow us to define that the application is a certain state. So we make a request to the application, and we want that the application returns a specific response containing specific values or specific strings in the HTML. And for this, Symfony offers the web test case object, which is an object that integrates into PHP unit. Who has written or used PHP unit in some way before? Everybody except maybe some? Yeah, okay. So who has not used PHP Unit before? 1, 2, 3, 4 people, okay. And PHP Unit allows us to use this, actually to run tests, and the web test case is the integration point for Symfony. So we have this test case, and it has some methods which allows us to run this functional tests. There's also a Symfony2 extension for Behat, which is a different testing tool, and then PHP Unit. But it's using mostly the same components that I will show later. So Symfony has 3 or 4 components used for testing, and these are used in both the web test case and the Symfony extension for Behat. So how does a web test case or a test for our application look like? So we write a PHP class, and instead of extending the PHP Unit base class, we are extending the web test case. Can everybody read this, actually? Yeah, it's good to read, okay. We're extending the web test case class, and this class offers us one method which boots the whole Symfony application and allows us to write this browser test. So when we call the createClient method, we get a client object back, and this is actually the browser that we are now using to serve our application. And you can see here that we can actually call the request method and tell the client where to go on our website, and it will return objects that allow us to make these assertions. So we have this crawler object returned, and we can also get the raw response content and this. So you see there that we make an assertion for specific degrees displayed on the website when we visit a specific site. Okay. So what you need for this as well is the PHP Unit XML file, and this has to be in the root of your directory or in the app directory of your Symfony application. And then you can run PHP Unit, and it will use this information from the PHP Unit XML file to know about your Symfony application. So the line where you specify the server dir, the kernel dir, this is actually important for the web test case to find your application kernel. This is the only thing that the web test case needs. And then it will, in your tests, instantiate the kernel of the Symfony application and run the test against this. And it will do so in every request. Whenever you call createClient, it will create a completely new Symfony application. What is this client, actually? We should take a look at it in more detail. The client is an object which comes from the browser kit component of the Symfony framework. And the browser kit component is actually only really used for testing. And the primary purpose of the component is, as I said before, simulation of browser sessions, and it handles cookies and the session and the history that you have in your browser. So whenever cookies are set in the application, then the client actually knows about them and keeps them for the next request, so you don't have to take care about this. And it actually works in a way where, as I said before, it takes the kernel of the Symfony application and just wraps around this. So the Symfony kernel, or the kernel interface, is something that is very, very important for the Symfony ecosystem. And the browser kit actually uses this HTTP kernel interface, which has the method handle and gets a request and creates a response, to wrap around this and create the requests and responses from this kernel. And yeah, this is actually one thing why the HTTP kernel interface is so very important for Symfony, because it's very easy to write this browser session client around this. So they're creating a request and sending it to the kernel, and creating the response is just very few lines of codes actually in the browser kit to simulate a request against your Symfony application. And if you want to know more about the HTTP kernel interface and how this actually works in different scenarios as well, then you should go visit Igor's talk later about the HTTP kernel interfaces Eberlei. Okay, then there's actually another implementation for this browser kit client object, and this is a library called Gute. And the difference between those two implementations, the browser kit that is used in the Symfony testing and Gute, is that in the Symfony functional tests, everything is actually run in the same process. So if you have 10 tests, then you have actually 10 Symfony applications inside a single request, and they're always run in this single process. And there's no actual TCP/IP communication going on there. It's all in memory in the same PHP process. And Gute actually puts the real HTTP layer between this by using the excellent library Guzzle, a HTTP client, to send the requests to a real server and get a real response back, and then turn this into the API of the browser kit component. And there was a talk about Guzzle yesterday. If you want to know more about this, you probably have to find and look up the slides if you haven't seen this. Okay, these are the only two implementations of the browser kit that I'm actually aware of. The one doing this all in process, which is done in the Symfony function tests, and Gute, which actually has a real HTTP and TCP/IP connection between this. So what can you do with the request method on a client? This is actually the method which is very important on the client. That you always call request and give it a bunch of arguments, sorry, specifying what request you actually want to execute. So the first parameter is the method. You can obviously say get, post, put, delete, patch, something. Then you give it the relative URL to your application. So you don't have to specify a host or something. You just give the relative URL / for the homepage and / something else for everything else. And then you have like a bunch of optional things. You can add post parameters, files, headers, and environment variables, or the post body string. So you can essentially configure everything that you need to execute such a request. And when you execute such a request, as we've seen before in the example code, it will return a crawler object. And this crawler object is actually from another component of Symfony called the DOM crawler component. And this is a component which has just one goal: to simplify traversal on XML and HTML strings. So PHP has its internal DOM document API, which is rather cumbersome to use if you want to traverse the XML or HTML trees. And the DOM crawler simplifies this a lot. And it takes jQuery as an sort of inspiration for its API. So we have this crawler object, and we can start adding CSS selector and XPath expressions to like traverse, and then have some additional methods to extract values from the HTML or XML. As I said, there are two traversal languages. XPath is always enabled, so you always can use XPath if you want. Who knows how to do XPath queries? Very few people, yeah. XPath is complicated somehow, and it's pretty powerful, but it's like, it can be simplified quite a lot by using something called CSS selectors. And this is where a third component comes into play that Symfony has, the so-called CSS selector component, which allows you to write CSS selectors like you would do in jQuery. and then translate them into XPath internally. Yeah, every client request returns a crawler instance. There's actually one thing that's annoying about this API, and quite a lot of times you actually don't need the crawler, but you want to operate on the response and then get the complete response, or for example, get the status code or some certain header of response. And for this, you actually need to call a method getResponse on the client object to get the last response that was created from a request method. This is sort of a little inconsistency in the API that is a little bit annoying, but easy to spot if you know about this. Okay, so this is an example of filtering using an XPath expression. So again, we create a client and we call the request method on it and go to some URL and get a crawler back. And now on the crawler, we can call filter XPath, give it an expression, and it will return a new DOM crawler object. Like in jQuery, it would always return a new jQuery object. And then you can call additional methods. For example, in this case, we're converting everything in this node and the subnodes to text, and then make an assertion on the text. So we are making an assertion that in a certain XPath expression, span with ID temperature, we have like a certain text giving the degrees of temperature at a specific location. And then we're using a PHP unit assertion, assert regex, to actually like combine the two, and PHP unit will then check, is this assertion true? Then the test passes, and if it's not, the test will fail. The same with CSS selectors, and in this case, you actually, it looks very similar, but the CSS selector is simpler to write. You have to call the filter method on the crawler, give it a CSS expression, selector expression, and it will, again, return a new DOM crawler object, and you can call text again on this method to do the same assertion as before. Then, this is just a slide which probably just too much to look at in a simple time. There's actually a bunch of methods that allows you to extract more data from the DOM crawler. Like you have an equal method to check additional stuff, or you can extract values from attributes of HTML elements. You can get the first, second, and last elements, for example, of a list of DOM nodes that you have. There's quite a lot of stuff that's actually exactly working like in jQuery, the traversal API. And you can look up in the documentation if you need more of this, or in your tests. It's actually, normally not very easy to remind this and remember this in such a short time. There's two additional features that the client and the DOM crawler actually provide for you, and this is allowing you to click on links and submit forms. So whenever you do a request to a page, then there's obviously lots of links in it and forms, and you could now go and extract the values that you need from the page using the traversal API, and then construct a new request on the client, submitting the form, clicking a link or something. This is actually quite, this would require quite a lot of code to get working. So the click links and submit forms API simplify this quite a lot. As I said, crawler and client interact together. The benefits of this API is that you're looking at the web page in terms of, You're looking at the web page in terms of real user interaction. You have a browser object, so the API sort of should look like a browser, and you should write the test like a user would use the application. So a normal test should look like I go to the first page or some page on my application, and then you should test the working of the application by actually using user behavior, clicking on links, submitting forms, because only then you can actually verify that the links exist and the forms exist so that the user can actually really see them and use them, instead of like calling multiple requests after each other without verifying that the user actually has the possibility to go this way. Also, it simplifies your tests or makes them more maintainable because you don't have to depend on the URLs of the application anymore, or how the URLs look like, because you can say, click a link named this way or that way, and it's actually not important anymore what the actual link to this site is. Okay, how does clicking links work? It's actually very easy. Again, we're doing a request, and then we are calling the select link method on the crawler, and we give it in either the actual text that is in between the H tags, or an ID, for example, of the link, or a name, I think, as well. And then we can call the link method on this. So we're turning a DOM element into a link instance, which is just a way of Symfony knowing to create a specific link object internally, which we then use in a next step to click the link on the client. So the crawler doesn't know about how to make requests. The crawler only knows how to crawl a website and look at it. And then we're using the crawler to create a link, and this link we send back to the client to actually do something with it. And then again, we can make assertions on the next site, what happened again. So clicking a link actually does a new request, returns a new crawl object, and we can go and do additional assertions on the next site. The same for submitting forms. The API looks sort of familiar. You call a select button, and you give it the name of a submit button of your form, either the value again or an ID field or something like this. Then you turn it into a form, calling the form method, and then you submit the form. And now for forms, in difference to links, you also have to provide values that you want to attach to the specific fields. So as a second argument, you pass an array of all the data that you want to submit with the form. And again, you get a new crawler back, and you can do new assertions on the site that was submitted. Okay, so this is sort of like the API of Symfony to write tests for your application. And showing this in examples is mostly very easy to understand how this works and how this looks like. The complicated or the complications start with actually your application being stateful or having a database requiring sort of some specific state before you can actually run the tests. So seeing this test before was actually quite easy. The question is, how did the data actually get into the database to allow me to do this assertion? And for example, for websites that use the security component a lot, how to actually make the session in such a way that the user is allowed to view the page and can actually like sort of see the stuff instead of seeing a 403 HTTP exception. And this is where the test setup considerations come into play, and this is actually the case where you have to like sort of adjust this to your application and to your needs. And one of the questions that comes up first is, should I use a shared or an isolated fixture? And we see in a minute what the difference is and why we should care. Also, how do we set up the database to actually allow us to run the tests? And how to configure the security component or how to work with security to allow us to view the page that we actually want to test. So shared versus isolated fixture is actually, a fixture is code or data configuration files that put all databases in your application in a specific state. So you define your application should have 10 users, 10 articles, 100 comments, and they should be related this and that way. this is a fixture. And you can now decide, or you may wonder, if I want to run tests, do I have to define a fixture that is used in all the tests, so you have certain specific data that is used for all the tests, or do I need fixtures that are specific to every test because I want to test edge cases and all this? And also the question is, should I create the fixture just once before running all the tests, or should I create the fixture for every test again and again, so that the database is always in a clean state and it can start again? So a shared fixture is a way of using like sort of a state in a database in every test, in all the tests in combination. So when the first test changes the username, then the second test actually has to change username. And this is the downside of this, using this shared fixture, is that you have to actually think about the order of the tests and how they run, and that they don't run in isolation, and that the changes in data can actually affect the other tests. The benefit of a shared fixture is that you only have to change or put the database into the state a single time. If you have 100 tests and you always like recreate a certain specific state, then this can actually take a lot of time, because this is obviously I/O. We have to delete all contents in the database, recreate the database in a specific state, and it makes the tests quite slow. An isolated fixture in a difference uses its own data for every test, and it recreates the database in this state. And this has the benefit that we don't have to care about the state or the order of the tests anymore, but the downside really is that you have to sort of manage the fixtures for every test, and this can easily lead to quite some micromanagement where you start like changing some field in some database or somewhere, and then you actually have to adjust hundreds of different fixtures that every have like different users something. So this can be quite a lot of work. So there's actually a trade-off here in place where isolated fixtures are much harder or take a lot more time to maintain. Also, they make their tests run slower, but they have like the benefit that you don't have to care about like the isolation, which is a huge plus, because when tests start to fail because of isolation problems, then it's really very hard to find out why, and it can take hours to debug this and fix this. And then, if you have this over and over again, you might like think about throwing the test suite away because it drags you down so much. The next problem with, or the next thing to think about in functional tests is the database setup. So the database obviously requires a specific schema, tables, columns, and whatever to exist. Also, if you use other mechanisms like Solr or something, you need a specific schema for Solr or Elasticsearch, and you all have to set this up. And the continuous integration environment requires you to automate this. So if you start your application and have like 10 tables, and then you have a commit doing an additional table or additional column in your tables, then your continuous integration environment that's running the tests automatically should not require manual interaction by you to change the database. So this has to be automated some way. So this requires time of you to think about how to automate the setup of the database schema. And then additionally, the question is, database schema creation is very expensive. Like if you have 10 tables, you might not care. But if you like 200 tables, then this can take quite a lot of time to create, and then obviously makes your tests much slower again. And then there's the question of, should I, to say about this again. So So actually what I see people doing is recreating the complete database schema for every test. So whenever you run a test, they always would like drop the database, create database, and create the complete SQL schema for every test again. And this is obviously something that is not changing for every test. During the run of like the test for one commit, the database schema is actually a fixed part, so you can just create it once. And the best thing to do here is actually to decouple the creation of the database schema from running the test. The test should actually not really do this, but you should use, for example, if you're using Doctrine schema tools for this, your continuous integration environment should first create the database and then run the test, and this should be two separate commands. So the test should actually assume that the database is in the correct state. And this is easily to verify in your tests because probably the tests will all fail if it's not the case. So if you separate this, this is actually the best way to do it and also the fastest way to run the test. You should never recreate the complete database for every single test case. Except if you're using SQLite databases for your tests. So there's the possibility, if you're using Doctrine ORM, for example, that you can run the tests against the database, not against your MySQL, PostgreSQL database or something, but use SQLite in-memory databases. And this is so much faster because it's actually in memory and it doesn't produce any I/O overhead. The problem with this is that it's only working if you're using the ORM without any specific database features. But if for simple applications this is actually possible for you, then you will see that your tests run much faster. And for SQLite in-memory databases, you have to recreate the schema every time because obviously when the test is over, the memory is freed by the operating system and the database doesn't exist anymore. So this is the only case when you recreate the database every time. What you should do with Symfony specifically is to share the database connection between every test. So when you use the Symfony functional testing and you don't take care of this, Symfony will actually connect to MySQL again and again on every single test. So and if you have, this normally is no problem, it just runs very slow. The problem is like when you get to test number 101, then MySQL in its default connection doesn't allow you to create an additional connection. So you have, your PHP process has 100 open connections to MySQL, and MySQL doesn't allow 101 connections simultaneously open. So then all the tests after that will fail and say like too many connections, too many connections. And this is normally the first time when people realize, okay, there's something really slow happening here. We are connecting every time. And connection to a MySQL server is actually one big part of the slowness of using MySQL. And if you're using Oracle or PostgreSQL or something, it's actually much slower. MySQL is quite fast in the connection, and these databases are slower. So the trick is actually to use a shared connection, only a single connection, to show you how you can do this. So I talked about fixtures. The question is how to actually load them. Seeing the functional testing and how it works, people normally, or developers I know or work with, they easily understand and can do this. The tricky part is how to actually make the fixtures work, and there are lots of questions on the documentation for all this, and people doing this in IRC channel asking, how can I actually load the fixtures, and how can I actually like use a shared database connection, for example. So there are different solutions. The most simple one is go into your development application and actually make a dump of the database into an SQL file and use this as a shared fixture. So you like have 10 users, 10 comments, 10 something, and this is enough for you to like do simple interaction with the application. So just make a dump, and in your test case actually file get contents on the SQL and pass them to PDO, and let's just write all the insert statements into the database. This is a very simple way of loading fixtures. And it's actually very easy to maintain as well. If you want to put your data in a specific state, just load the fixture into MySQL, then like open up phpMyAdmin, change the data as you want, and just save the changed file again. So it's very easy to maintain. Then there's PHP Unit's DB unit extension XMLs, which is sort of like XML on top of SQL insert statements. It's also quite easy to use, but yeah, in combination with Symfony, it might be a little bit difficult to set up. And then there's the possibility, if you're using Doctrine ORM, to use Doctrine fixtures, or if you're using Propel, they also have some kind of fixture tools to use, where you use the actual Doctrine or Propel objects to like create the database in a specific state and use this. And using Doctrine fixtures actually makes sense if you're using the Doctrine fixtures for something else as well. For example, initial installation of the application, or if there's more stuff going on than a simple SQL dump can do on setup of the application. Yeah, the most important thing is that you should really keep it simple, because when you need to invest a lot of time into keeping the fixtures in a specific state to actually have your tests run, then the problem can occur that either your product manager or your boss says you are taking too much time writing tests, or you actually are fed up with it because you don't want to spend 4 hours like changing the fixtures because you made a change in the database, and you just skip running tests. So the most important thing about fixtures is this should be very simple to maintain and change, so that you don't feel pain in doing it, because then there's a very high likelihood that you at some point will drop testing, or somebody will force you to do it. So loading fixtures is actually quite easy, and this is very important. In your Symfony project, you will always, or should always, create a base, your own base class extending from the web test case and doing stuff with the kernel that you need. So this is the way it looks like. You extend the kernel and override the create kernel method. And yeah, you have the comment there, fixture setup here. In this case, you actually, having the kernel allows you to access Doctrine, for example, to insert an SQL dump using the exec method on Doctrine, or you can use the ORM, or you can use the fixture library from Doctrine to do stuff there. Essentially, at that point, you can do everything you need to put the application in a state. If you have Redis and you need data in Redis, then you do it there, everything else. Yeah, this is the place actually where this is very specific to your application. Then I talked about using shared database connectors, and this is the way you would do it normally. So you would extend the kernel, the create kernel method a little bit more. On the first run of all the functional tests, it will realize that you haven't created a Doctrine database connection ever before, and it will retrieve this connection from the dependency injection container, save it in a static variable, and then on the next run, it will actually realize the connection is already existing and set it on the container for the next test. And this way, you would actually have only a single Doctrine database access layer connection, or a single PDO connection to your MySQL, PostgreSQL database. And yeah, this has the benefit of like removing these failures, too many connections, and also makes the tests run much, much faster. One golden rule for any kind of database or I/O or something tests which need fixtures is that you should not delete the fixtures or the database and tear down. So normally in PHP unit tutorials or something, they tell you that on setup you create resources, on tear down you delete them again for the next run. This is actually not very helpful if you do this with databases, because whenever something fails in tests that are using the database, it's very helpful to actually look at the database after the test fails, what went wrong. Because this is actually the thing that you're testing interaction with your data. And if this is failing, you want to take a look at what the data did during the test. And this is why you shouldn't delete it in tear down, so that you can actually use PHP myadmin or something else, look at the data and see the problem that caused the failure of your tests. The next thing you have to consider is the security component. So if you're using, or generally having to log in into your application to use specific features. So the first thing that you might think about is just use the real authentication mechanism. So in every test, before we actually do something, we visit the login page, enter the credentials of a valid user, and log in for the user. And as I said before, the browser kit or the client actually knows about cookies and about the user session. So after logging in, you will have a client that is logged in as this user, and you can browse the website as this user. The problem really is, if you think about it, then for every test, you would hit the login page, log in, and then it would redirect to some dashboard or something. So you have actually 2 or 3 requests, depending on how you want to implement this, that handle authentication. And these can already take like 1 or 2 seconds. So every test is like 2 seconds slower just because you have to log in into the page before. And yeah, it takes 1 or 2 seconds because the test environment that we're using inside Symfony is actually also having the debug flag enabled. So it tends to recreate the container or do stuff that is quite slow. Then the next thing that you could think about is, okay, just let's disable security completely for the tests. So you create in the config test YAML of your Symfony application, you disable security. And this works if your application doesn't actually depend on the user object or use the isGranted method or something. But this is rarely the case. You often have like interaction with the user object or something, and then your complete application would break because in the test environment, the security component wouldn't have a user object or a token or something else and would just fail. And this is also not very good because you're changing the behavior of the application so much that you can actually not test it in a real environment. It's sort of quasi very changed environment. Also, disabling authentication obviously doesn't allow you to test specific features where you're using the security component. For example, you might to test that user A is not able to access something that user B created. So the third solution, which is the one that is favored mostly, is to change the authentication strategy just for the tests. And the obvious solution or the obvious authentication method that comes to mind is using HTTP basic authentication instead. So in your config test YAML file, you would change the firewall of your application to not use form login anymore, but to use HTTP basic authentication instead. And then in your tests, while creating the client object, you can pass the credentials of the user that you want to log in with. And it will send them via HTTP basic authentication and do this on every request. And then you don't need to take care about logging in your users into the application. So this is considerations about setup. And I want to take a little detour into Behat. And Behat is a tool that allows you to do so-called behavior-driven development, where you focus on the behavior of the application and test this. And Behat uses the so-called Gherkin language to create human-readable descriptions of your tests, and then it turns them into code, or it matches the language to executable code, and then makes running tests out of this. And Behat has there's an additional project called Mink, which allows you to write these tests using a browser language again. So exactly like the Symfony client object allows you to write or to operate a browser using PHP code, Behat allows you to do this using a very simple human-readable and human-writable language. And Behat is actually implemented using lots of different Symfony components. So the CSS selector component, for example, is used inside Behat, and the DOM crawler probably as well. And the Symfony, if you're using the Symfony2 extension for Behat to test your Symfony application, then actually Mink and Behat is just a layer on top of all the APIs that I showed to you before. And this makes it more simple to use. So how does how does a Behat test look like? So this is just a very simple text description of the test, and this is executable for Behat. And it does exactly the same that we've seen before in one of the other PHP unit-based examples, going to the weather website and entering a name into a form, pushing the show weather button, and then looking on the response of the next site. And the benefit of this is that actually the different steps that we implemented in PHP code, where we actually used quite a lot of PHP code to do this, are abstracted in very, very simple sentences. And if you're starting to write quite a lot of functional tests for PHP, for Symfony, then you will see that you have lots of duplicated code in your tests. And a very good abstraction is actually making sentences out of it to look like this. So let's Behatify our web test case that we've seen before, and for the different steps that we do, we actually create methods on the test case that perform the different steps. So the first step here is give an IAM on, and you give some specific URL, and the next method would be when I submit, and these are like very generic methods that allow you to perform operations using the browser client. Then you can see the test as the last method here on this slide being very, very simple and descriptive about what you actually do as a client using the website. And this will reduce lots of code in your functional tests. If you're using the API very rawly in every test, then you have lots of duplicated code, and the tests get harder to maintain in the long run. Okay. This also allows you to do stuff like if you want to reuse a bunch of steps in one step. Let's say we have such a language that allows us to describe working on a page, then we could add a composite method that is called if I am a logged in user with this and that authentication level. And you can group the steps that you need to do this, and you can reuse this code everywhere in your application. Okay, and this is about it, about testing Symfony applications as an HTTP black box. One additional step is like actually having integration tests for smaller parts of your application. So just writing this kind of tests I showed before is first very slow. If you have 100 tests, it might take 3 to 4 minutes to run them, or longer, depending on how expensive your setup is. And you may want to test it, for example, doctoring queries or something like this in a much more detailed way, changing different parameters, looking at the interaction that the database did. So for this, you actually want to test, or you need services from your dependency injection container configured in a specific way. And you don't want to recreate all the different configuration parameters that you have given to the Symfony dependency injection container, because you already did this once. So what you want to do is have some kind of integration tests that have access to the dependency injection container. And this is actually also the case because you don't want to, if you're writing a lot of unit tests, you don't want to always mock all these APIs away. So having the Doctrine Entity Manager and starting to mock this will make you go nuts, because the Doctrine API is very, very big and has tons of possibilities. And starting to sort of simulating this in your test will always miss something. For example, if your code relies, or a test relies on an insert operation and then a select operation that does an order by, then this is something very, very specific to your application that you can't mock away in a test. You always have to run this sort of using the database, because the order by actually depends on the insert and the data and stuff, and so this is quite complicated. Also, if you're mocking away web services, that at some point the web service will change and you don't realize this. Or something that I often encounter, people mocking in their tests the dependency injection container from Symfony, and then saying, if I call this get method on this on the container, return this and that service. But the dependency injection container is actually case insensitive with regard to the service IDs. And if your code is very inconsistent about service ID naming, then it's actually quite annoying to specify the different cases in your mock objects to allow this. And this is just a very subtle change in, or subtle behavior in your API that you can miss. So the solution is use the container and construct this in your tests, and it's using the Symfony test environment. How do you do this? I hope this kind of class gets into the Symfony core at some point. I always create it. It's called a kernel test case. And what it's doing is, in this case, it's extending from web test case. People are always thinking, this is a web test case. I can't really just not test something that is web. So the naming is sort of bad, because we also want to test the application in a little smaller way and not have this HTTP black box testing in some cases. So here you create the kernel and you specify environment test and debug true equals true, and then you boot the kernel and you retrieve the container from the kernel and put it in an instance variable of the test case. And on shutdown, you actually shut down the kernel. And then you have your own tests and you do something like this. But I think I forgot to call the parent method here. Yeah, so you have to obviously call parent setup here. And then you retrieve services from the container and stick the object that you want to test together using all the services. And then you run operations. So you call specific operations against the database. And obviously, in this case, you also have to handle the setup of the fixtures and loading this. So everything I showed before about fixture loading and database setup is true for this case as well. So this is a way of testing services from your container, or with services. And actually, one thing that I do in most applications is have one specific service which has a list of all test, which has a list of all service IDs that you defined, and then try to create them. Because one kind of test failure I have quite a lot in my applications is forgetting to change some definition of my services. And then in my unit test, obviously everything is correct, but when the dependency injection container tries to create them, then there's something missing, a parameter or something changed. So this is a way of sort of having a compile step or test step for all my, my own services. Okay, I think I'm over time already. But does anybody have some very small questions? Yeah. Which one? IC test case? I don't know this bundle, so I can't recommend it. No, I don't. I know the Leap functional test bundle. Ah, okay. No, I'm not sure. Normally, I do all this myself because then I have more control over it. Yeah. A builder object or something like this? Normally, I think that so you ask if I like abstract the creating of objects and this in some specific objects or something like this. Normally in your test, you should always drive refactorings for the tests based on duplication. Whenever you see lots of duplication in your tests, you should think about how to abstract the duplication away. And then the solution for this is something very specific for you. Depends really on the kind of duplication you have. But once you're seeing duplication in your test, you should try to create new objects or something like this, allowing you to reduce the duplication or get rid of it completely. Does this answer your question? Okay. More questions? No? Yeah, if you have more questions, I will be around the whole day, obviously. Just come up and talk to me. And if you want to stay in touch, again, this email address and Twitter nickname. And thank you very much for listening.